Hi friends, welcome to GMK tutorials. So ఇప్పటివరకు ఇంకా ఎవరైనా మన ఛానల్ సబ్స్క్రైబ్ చేసుకోకుండా ఉంటే so please subscribe our channel. Okay. So let's move on to the today's topic. So today we are going to discussing about the shift invariant feature transform. So already we did a video on this topic also. Just a quick review on this one. So in this case, so first one is construct a scale space. So you have to create a scaled image, then take a difference of their Gaussians and locate the DOG of extrema. That means based on the extrema point, you can locate the corresponding difference of their Gaussian and the potential difference of the feature point, and you have to reduce the corresponding edges and contrast points of the corresponding images also, as well as after that, once you can remove the edges and the contrast point, you can assign a key point orientation to the corresponding key point based on the local gradient and build a key point descriptor for representation. Why? Because the first step is nothing but just you have to take the difference of their Gaussian for location of the corresponding key point, After that, you have to remove the edges and contrast points on the corresponding images. After that, you have to orientation is very important. So just you have to assign a key point orientation to identify the corresponding edges or maybe corners in the corresponding image. So third one is nothing but once you will identify the corresponding key point orientation, you can represent the corresponding points also. That means if you want to compare the two images, obviously the corresponding key point also must be matched. Then only we can say that those 2 points are same. So for that purpose, the key point descriptor is also very important. Okay. So there are different variants of the shift. So one variance, that is nothing but speeded up robust feature. So it is also simply called as a SURF. SURF. Simply we can call it as a SURF. So in this one, just there is a small difference between SURF and shift is just the corresponding DOG filters and as well as location of the just we'll go back once. So here take a difference of Gaussians and locate DOG of extrema. These two fields can be replaced with a box filters. So these box filters are approximately equal to the difference of the Gaussians is also approximate to the Laplacian filter. The same operation can be performed by box filters. So box filters is nothing but very faster compared to the Laplacian filters, and we can also identify the corresponding points in the horizontal direction, vertical direction, or else we can also in the diagonal directions also. So after that, you have to perform the same operation like subpixel locate potential feature point. That means once you will identify the corresponding key points, you have to identify the location where exactly the key feature is present in terms of a scale as well as space also. After that, is there any point beyond the corresponding points? Just you have to represent the we can also call it the extrema location. We can also trace of h by delta of h, trace square h by delta of h. That means based on the local extrema, we can eliminate the edges and contrast point based on the measure of the cornerness. So after that, assign a key point orientation. Once you will identify the location of the key points, you can assign the orientation to the each and every key point based on their local gradients. After that, once you will identify the orientation of each key point, then you can describe the corresponding features by using the key point descriptor. Why? Because if you want to identify the two images are same, means that obviously you have to compare the corresponding points. So the location is different. So for that purpose, you have to describe the corresponding key points based on the local feature. That is nothing but simply we can also call this a gradient like. Okay. So this is just a block diagrammatic difference between the SURF and shift. Coming to the advantages point of a SURF, it is nothing but by using in case of the SURF, we are using the box filters instead of Gaussians to approximate the Laplacian filters. We are using a box filters. These box filters are variety of shapes, like it is in the format like this. It may be black and white combination. It may be in this, maybe it may be also in the diagonal fashion also. So these are the different variations of the black, white, suppose 2, 1, -1 like this. So there is a different variety of box filters are available. So with that we can identify the corresponding directions and key points locations based on this box filters. Moreover, we are using the Haar wavelets to get a key point orientation. The Haar wavelets are very faster compared to the remaining filters. That's why the speed up of the surface is also very good because of these Haar wavelets also. As well as surface handling is good at handling blur and rotational variance. That means, is there any noise in the corresponding image? Is there any variations in the corresponding images? We can identify the surface a good handling. Such a kind of the problems also can be handled good with the help of a surf filter, because of but shift is not that much of good for blurriness as well as rotational variance also blur. So as well as it is not good as shift on invariance to illumination and viewpoint changes. So the shift as well as surface also having some limitation. That is nothing but if there are any changes in the illumination at that time, the surface is not that much of a good. That is the one more limitation in this one. As well as surface also 3 times faster, approximately almost 3 times faster than shift. So this is just a brief introduction about this surf. Surf is one of the variant of shift only. It is not a separate one. It is one of the variant only. Okay. I hope it is clear. Just I will recap this one once. So the basic difference between shift and the surface, the difference of the irrigations, the difference of these two. So just a variation in this one is nothing but just these two stages can be replaced with a Laplacian. These two stages can be replaced with a box filter in case of the surf. So that is the only basic difference. Just you have to take this. So these box filters are very faster compared to the Laplacian of Gaussian. So for that purpose, this surf is very speed in terms of their performance also. So these are some of the advantages and all the advantages of the surf compared to the shift. So that means the Gaussians of the difference is also a very lengthy process. That means you have to take the difference of the Gaussians and after that you have to locate the key features based on their local space as well as scale point of view also. So Haar wavelets are very good for performance point of view. So that's why this surf gives a very better, faster compared to the shift. As well as it is also having some limitation. That is nothing but just if there are any illumination changes in the images at the time, the surf cannot produce a better result. So but the shift can handle such a kind of the problems very effective also. So this is it is a very almost 3 times faster than shift. So this is just a brief introduction about this surf. So thank you for watching GMK tutorial. Thank you.